Hello guys, my name is Prince and this is Math Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it. We are on the topic mensuration. In the previous video, we considered a hollow cylinder and we learned how to find the total surface area, curved surface area and volume of a hollow cylinder. In this video, we are going to consider annular cylinder. Annular cylinder. The picture that we see here is an example of an annular cylinder. So it's like we have one cylinder that is fixed into another. If you have an annular cylinder, from the center to the inner cylinder is called the distance from the center to the inner cylinder is called the internal radius. So in this diagram here, the distance from the center here to the inner cylinder, to the surface of the inner cylinder or an end of the inner cylinder is called the internal radius. And the distance from the center to an end of the outer cylinder is called the external radius. A typical example of an annular cylinder is a pipe. So if you have a pipe, you can see that it looks like the picture that we have here. The distance from the center here to the inner cylinder is called the internal radius, represented by a small r, and the distance from the center to the outer cylinder is called the external radius, represented by big R. The distance from the top to the bottom of the cylinder is h, that is the height of the cylinder. If you have an annular cylinder like this, we will say that in order to find the cross-sectional area, the formula is pi r squared minus pi rh, where the first r is the external radius and the second r is the internal radius. So pi big R squared minus pi small r squared. To find the volume of the cylinder, the formula is pi r squared h, where r here is the small r, that is the internal radius, and h is the height of the cylinder. And to find the volume of material used in making the cylinder, the formula is pi big R squared minus pi small r squared into brackets times h. That means that, let's say that this annular cylinder we have here is a pipe. To find the volume of the plastic or metal used in making the pipe, the formula is pi the external radius squared minus pi internal radius squared times the height of the cylinder. Let's pick a question and see how to apply these formulas. A cylindrical pipe is 2.8 meters long. Remember that a pipe is an example of an annular cylinder. Its internal radius is 3.5 centimeters and its external radius is 5 centimeters. Calculate, correct your answer to one decimal place, the cross-sectional area of the pipe, volume of water the pipe can hold when full, and volume of plastic used in making the pipe. Give your answers in centimeters. We have been given the height of the pipe here to be 2.8 meters. It's in meters, but the question said we should give our answer in centimeters, which means that we have to convert this from meters to centimeters. Okay, so the height is 2.8 meters. If you convert it to centimeters, you have 280 centimeters. So you multiply 2.8 by 100 to convert it to centimeters. The internal radius, which is small r, is 3.5 centimeters. That's what the question told us. It said the internal radius is 3.5 centimeters. And the external radius was also given to us as 5 centimeters. So small r is 3.5 centimeters and big R is 5 centimeters. The question said we should find the cross-sectional area. The formula is pi big R squared minus pi small r squared. And this will give us pi times 5 centimeters squared minus pi times 3.5 centimeters squared. If you find this on your calculator, you are going to get 40.1 centimeters squared. So you find this on the calculator, then you correct your answer to 1 decimal place, just as the question told us. This means that the cross-sectional area of the pipe is 40.1 centimeters squared. Okay. The question also said we should find the volume of water the cylinder can hold when full. The volume of water the cylinder can hold when full is the same as the volume of the cylinder, because the volume of the cylinder will determine the amount of liquid that the cylinder can hold when full. So the volume of water the cylinder can hold when full is the same as volume of the cylinder. To find volume of this cylinder, we have learned that the formula is pi r squared h, where r here is the internal radius. So this will give us pi times 3.5 centimeters squared times h. We want our answer in centimeters, so we are going to use 280 centimeters. When you do this on your calculator and you correct your answer to 1 decimal place, you should have 10775.7 centimeters cube. That means that the volume of water the cylinder can hold when full is 10775.7 centimeters cube, which means that when the pipe is full with water, the volume of water in the pipe is 10775.7 centimeters cube. The question also said that we should find the volume of plastic used in making the pipe. The volume of plastic used in making the pipe. We learned that the volume of material used in making an annular cylinder is given by pi big R squared minus pi small r squared times h, where big R is the external radius and small r is the internal radius, and h is the height of the cylinder. So the volume of plastic used in making the pipe is equal to pi big R squared minus pi small r squared times h, and this will be given by pi times 5 squared minus pi times 3.5 squared times 120 centimeters, or times 120. When you do this on your calculator, you are going to have 11215.5 centimeters cube. This means that the volume of plastic used in making the pipe is 11215.5 centimeters cube. So for an annular cylinder, you need to note these formulas and you use them whenever you are being told to find the cross-sectional area, the volume of water the cylinder can hold, or the volume of the cylinder, and the volume of plastic or material used in making the cylinder. Thank you for watching this video. Subscribe to this channel by clicking on the subscribe button that you see. In the next video, we are going to consider another solid figure. The solid figure we will be considering is a cuboid. So we will learn how to find the total surface area, curved surface area, and volume of a cuboid. Bye bye.